Okay, continuing on with section 8.1, part 1. Now we have come to the part where we need to start talking about this ambiguous case. So anytime we are given a side angle information, or easier to remember as angle side, these are the kinds that we have lots of options that could happen. And so I actually created a flow chart. This kind of breaks it down a little bit. If you have obtuse triangles, so this is saying if angle A, the given angle that you are given, is obtuse, then one of these two instances could happen, where you see if side A across from angle A has to be longer than side B, otherwise the triangle isn't gonna happen. So that's the first case that you have to look at. If angle A is obtuse, then you have to check the sides that are given and make sure the side opposite the obtuse angle is longest. Okay. Then the second situation, if angle A is acute and side A is longer than side B, then you have one nice triangle. Everything works out great. However, which one is this one? This is if B is greater than A, then we have lots of things that can happen. And we have got a couple examples to go over these two situations right here. So let me show you what the flow chart shows. And I'm going to post this to our classroom, onto my Open Math. So, let's see here if we can move that down some. Okay, so this is our special case that we have. Given an angle, a side, and another side. So angle, side. The angle is not the angle between the two sides. So that's important, that when you're given this information. Oh, I can't draw. Hold on. I can't do everything at once, can I? Shoot. Okay, I'll just have to live with it like this. Alright, so it's important that when we're talking about these angle side situations, I'm going to put that in as a dashed line, that we have an angle A, a side B, and a side A. We are not given the angle in between the two sides. That would be side angle side anyway, but just to clarify that. Okay, so angle A, and side B are given like this. Then the first thing that we need to do is we need to check and see, is it acute or is it obtuse? Right? If it's acute, then we'll follow this direction. Then we're going to check the two sides that are given. If side A is greater than or equal to side B, then we have one nice triangle we can go ahead and solve without any problems. However, if side A is less than side B, then we are given this ambiguous case. And this is kind of the generic triangle I want you to be able to draw, because this is what happens. If we are given this information in this format, then the length of A could be this direction, or the length of A could be this direction. It's the same side lengths. Oh, I wondered where my phone went. Yeah, that's fine, but just you guys we'll give it to Cannon and Sage and whoever Sage wanted to play a game with him. Okay, so anyway, that's the situation. A can go this way, A can go this way. A is the same length both times. We just don't know what happens to our C value. So down here, this is a good, really good drawing, the best drawing I have seen of this ambiguous case and what can happen. So, and really this comes from the fact that when we take the arc sine of a side, then we can get two possible answers. And that's exactly where this comes from. So when we take the arc sine of a side, we can have a smaller number, and then we can do 180 minus that angle and get this. Well, I guess this would be our smaller angle over here. B sub 1 would be smaller here. B sub 2 would be greater here. So that's the situation that can occur here. If it's obtuse, then we have a couple of directions to go also. So A can be greater than B. If A is greater than B, then we just have one nice triangle, and we're good to go from there. If A is less than B or equal to B, then it's no solution. Okay, that's not going to happen. Okay, let me roll this up and then we'll come back. Okay, so we just scrolled up a little bit on our flowchart, and so this situation here is the one that keeps going. So if we get to this ambiguous case right here by following through our flow sheet, our flowchart, then once we get to this case, then we still have some decisions to make. So we're going to use the law of sines to determine if angle B exists, because that's another option. And so we're going to use our law of sines, and once you go through that whole system of law of sines, and then you take the arcsine of the side and try to find what angle B is, if it tells you there's an error, or better yet, if you're having to take the arcsine of a number greater than 1, then it's not going to work. Okay, so if you're trying to take the arcsine of a number bigger than 1, then you're going to end up over here. If angle B does not exist, then the answer is no solution. There's no triangle. There's no answer. Okay. However, if angle B does exist, then we've got to go over here to this 5-step process of solving an ambiguous case triangle. So step 1 is going to be to use the law of sines. You're already halfway done because you did this step up here. You found one value for angle B. Now you need to find that next value for angle B. To find that next value for angle B, you need to do 180 minus. Now remember, with sine up until now we've been using all radian values, so we've always done pi minus, but if you look at your unit circle, pi and 180 are equivalent to one another. Okay, so pi is what we're going to use in radians. When we switch to degrees, we're going to use 180 minus. Also makes sense because that's, how many angles you have in a triangle, how many degrees you have in a triangle. Alright, so from there, then we want to split into 2 columns. So on your paper, you just make 2 columns. Make one column for the angle B sub 1, so the first value you found, and then a separate column for B sub 2, because what happens is 2 triangles are possible. Okay. Step 3 is going to be to find C sub 1. So now we're working in column 1 with the B sub 1. So we're going to find C sub 1. Do 180 minus angle A plus angle B. Okay, then use your law of sines to find C sub 1. So what we're doing is we're just solving 2 separate triangles, each in their own columns. And then we're going to repeat steps 3 and 4 to find, I made a mistake there. I need to change that. So I'm going to change that to C sub 2 and side C sub 1, or sorry, C sub 2 in the other column. So go through, solve everything for B sub 1, C sub 1, and side C sub 1. Then go over to your second column and solve everything for B sub 2, C sub 2, and side C sub 2. Okay, so we'll go on and look at that. Okay, so I've got that changed there. So that now says repeat steps 3 and 4 to find angle C sub 2 and side C sub 2 in the other column. Okay, so going back to our notes now, let's look at, okay, so that breaks down this information better. And I will make sure and get that flow sheet out to everybody. Okay, so let's go on to example number 3. So example number 3, my notes here. Okay, you can see says use the law of sines to solve all possible triangles if angle A equals 100, side A equals 32, and side B equals 13. So now we have the information they give us. Is angle, side, side. So this is the case that we're going to need to use our flowchart with. So we go back, we look at our flowchart. First thing that we need to know, is angle A obtuse or is it acute? So in this case, we have angle A is obtuse. Okay, so after that, then we want to know what about the sides. The side opposite the angle given, which in this case is A. So angle A is greater than angle B. So let's switch over here to our flowchart. and see where we go from here. So first thing that we looked at, is it acute or is it obtuse? In this case, it is obtuse. Okay. And then we said angle A was greater than angle B, so that means that we have one triangle, so we can just go ahead and solve. We only need one solution. And then also something to know from here too, which maybe I'll add this on here, is if angle A is obtuse, then that means that our other two angles are going to be acute. And that's going to be good to remember, and I'll show you why in this example. So back to our examples. Okay, example number 3. We have an obtuse angle A. A is greater than B. Therefore, as we looked at on the flow chart, we have one solution, so we can go ahead and solve just using our law of sines, and we don't have to remember any of the ambiguous case. So we are going to get the sine of 100 over 32. So that's the sine of A over side A is equal to the sine of B over side B. Oops. What did I do? Yeah, sine of B. So angle B is what we're trying to solve. So cross multiply, we have 13 sine of 100 equals 32 sine of B. And then I'm going to divide both sides by 32. And so we have 13 sine of 100 over 32 equals B. So B, sine of B, is going to equal all of that. So doing all of that on your calculator, and I already did all this so we could go a little faster. So sine of B is equal to 0.40. And I got the 0.40 from calculating all of this information. Again, make sure you're in degrees in your calculator. So now we are going to take the arc sine of 0.40 equals B. And then again on your calculator, you will get B equals 23.578. Okay, now remember how we could always find a second solution when we're trying to find sine or the arc sine or arc cosine of something. So we could do 180 minus B, which remember normally we would do pi minus our first solution with sine, but we're working with degrees and not radians, so degrees is the 180. 180 is the equivalent in degrees to pi. Okay, so we could do the 180 minus B, which I already did that also, and that would equal 156.422. So the reason that I don't have to worry about this is because my angle A was already obtuse. In a triangle, we can't have two obtuse angles. That's why I know that this second angle, the 156.422, we cannot use that because we can't have two obtuse angles. So my first angle, it's always going to be my smaller one. So in this case, that's the only one that we need. Okay, so now we have angle A, angle B. I'm going to write them up here. Angle B we found to be 23.578. And now we just need to go ahead and solve for the rest of the triangle. So I'm going to go back to the first information that was given. The sine of 100 over 32. And then that is equal to, so C is what we still don't have. So we need to find the angle C, because we don't have any information at all about C, right? We don't know what angle C is, and we also do not know what side C is. Okay, but because we know what angle A is, and now we know what angle B is, we can find angle C. So we need to calculate angle C, which we will calculate the measure of angle C by doing 180 minus the sum of 100 plus 23.578. Oh, and I am almost done. So I'm going to go ahead and give you guys these answers. 27.072